Okay, guys, today we will study about the heat transfer process. What is heat? Heat, it is nothing. According to the dynamical or model theory, it is the increase in energy. Energy. So heat transfer is a process where we study flow of energy due to difference in temperature. The transfer studies non-equilibrium processes. Unlike thermodynamics, which study the equilibrium processes. Uh, okay, here we think what is conduction. We'll start with the conduction. There are different modes of heat transfer. How does the energy flows? The very first is conduction. Okay, but before going into the modes of conduction, I'll study a little bit about the laws of thermodynamics and laws of thermodynamics as well as laws of heat transfer. So what are the basic natural laws that governs the process of thermodynamics and heat transfer? We know that thermodynamics is governed by zeroth law, the first law of thermodynamics, the second law of thermodynamics, and third law, which is absolute zero concept. Whereas heat transfer is governed by first law of thermodynamics, also first law, which state that heat supply is equals to work done plus internal increase in internal energy. Heat supplied equals to work done plus increase in internal energy. Second law, second law, second law, which states that the reversible process is not possible without any addition of other energy or any assistance. So this is reversible process. So this law governs the heat transfer. Law of conservation of mass. I'll see like convergence, conservation, conservation of mass. Uh, Newton's laws of motion, which are of course applicable to the fluid flow, which are Newton's laws of motion. Other are rate equations. So these are the laws of which governs the rate of heat transfer process as well as thermodynamics. We'll study details about thermodynamics in next chapter. Let's start with the modes of heat transfer. So what is conduction? Conduction is the process of heat transfer uh, where energy carriers are free electrons and as well as due to lattice vibration. So lattice vibration and free electrons. And conduction heat transfer occurs. Here is a basic law of Fourier which say the rate of heat transfer is what the heat transfer joules per second is directly proportional to cross section area of the body as well as the rate of temperature gradient in that direction. If it is steady state, if it is unidirectional, you know, and there is a no heat internal heat generation, no internal heat generation, it is the material is isotropic and homogeneous. Kuraru. These are the things that we think we need to consider while applying this law to the conduction process. And of course, if we try to eliminate, there comes a constant which value is known as thermal conductivity, and it is a property of a substance or a medium. Property of substance or simply a medium. So we have known about the conduction process. Now we will look at the equation Ka dt by dx. So here, temperature acts like the potential V, and heat transfer acts like the charge, the current I. So if we try to compare it with Ohm's law, V equals to IR, we can try to find the analogy of resistance, which says that the resistance to the heat transfer R is defined as dt by d okay dt by q. So we know from here this is dx by ka is our resistance from this equation. This is known as thermal resistance. Now we will go into look into further, which is the second mode of heat transfer by convection. So in convection heat transfer, we have our Newton's laws of cooling to govern the process, which states that Newton's laws of cooling, which states that Q is directly proportional to area and change in temperature, provided H is written here. H is our convective heat transfer coefficient. Convective heat transfer coefficient. So where does this as depends on? This also depends on medium. This is a thermodynamic and transport property of medium, thermodynamic as well as transport property of medium. This nature of fluid flow also depends on nature of fluid flow, and also geometry and thermal conditions of medium. So if we try to frame the resistive heat transfer of convection, we get as 1 upon HA. There are other methods of heat transfer